secret too. Oh, you know I want you there, I wanna be right there with you. I know I gotta keep you by my side till the day I die. 'Cause baby, ecstasy is in my hand. Oh, when I'm holding yours in mine and walking in the sand. Oh, baby, you know it's fine. Now you done and piss me off. You ain't done something you shouldn't have done. Baby, I'm mad. I'm going on. Oh, I'm going on.
And welcome, everybody and nobody, individuals and zero people, because, you know, people can be watching and it still says zero people, apparently. I'm not saying that's the case now. But good morning, good afternoon, good evening, whatever it is, wherever you are. And thanks for joining me here at the EasyReefers Coastal Restoration Fish Room of Science. Today, I would like to discuss some very important common misconceptions or shortcomings of knowledge regarding reef restoration, and would like to address sort of a greater vision of unifying the ecological restoration of the ocean as a whole by finding financially sustainable means of doing it. And what that basically means is, how can we make money off of saving the environment? How can we increase profits while reducing, or not even just reducing, emissions and pollution, namely phosphates, nitrates, fertilizer runoff type emissions? But how can we actually have an industry set up that can take the supposedly acceptable levels of output of these industries into these streams? Take that contaminated water that's basically the ocean's top-off water and make it cleaner for a profit. Now, it doesn't have to be clean enough for human drinking water. It just has to be clean enough for top-off water. See, here's the deal. There is a massive restoration project underway in the Great Barrier Reef, off the coast of Florida, the coast of India, Africa. And even off the coast of Louisiana, where we do our little, well, we just dump crap out there and think fish can swim through it, and we call it a reef. Kind of retarded, but they don't want to listen to me, so. Anyways, I'm continuing to talk to people and trying to reason with them about how much money they're just wasting. But in a nutshell, what this video is about: imagine the most pristine aquarium setup you could possibly happen. Every reactor and controller known to man, messages sent to your phone about anything gets out of spec. Just the most perfect, flawless, gigantic aquarium with equipment so far in excess of its livestock conditions. Should be absolutely perfect conditions in there. Just absolutely perfect, pristine, the most beautiful aquarium in the world. Certainly the most expensive. But, and this is a big, dimply, cellulitic but, instead of filtering your top-off water with an RODI system, or instead of even using tap water, go to your local river. Take some of that brown, disgusting water from all the fertilizer plants and everything. I want you to take that water and use that for your top off. What you're going to experience is exactly what the ocean experiences, because the ocean tops off at the rate at which rivers flow the fuck into it, doesn't it? Oh, yeah. I'm sure you got rain as well, but so maybe mix 50-50 river water, 50-50 rainwater. Mm-hmm. Still doesn't look very good, does it? Still doesn't look very promising. If Mark Levinson or any other experienced reefers are going to watch this, they're going to be thinking, oh, the hair algae. Oh, the dead corals. Oh, the gasping fish. Oh, the disease. Oh, the disgusting results, the tragedy that would come, the pristine, wonderful reef tank that you could have built as if it were built by God himself. Ruined. You see, there was this weird old guy who owned a piercing parlor. Is it called a parlor? In New Orleans. In this little strip where a bunch of bars were, it was a happening place, right? And this guy was a character. To this day, I have no idea where he was from, but oh boy was he from there, okay? And he liked to brag about the cleanliness of his, what obviously looked like a disgusting fucking facility. Just a dirty little corner that he worked out of. But even he knew, and he would love to tell you, you take good water and you take dirty water. You mix it together. What do you have? Huh? Tell me. Dirty fucking water. And that's it, man. The ocean can be as clean as you fucking want. You can restore all the reefs that you want. But as long as you're dumping shit water in there, from the Mississippi, the Nile, the Ganges, the Mekong, river after river, dirty fucking water. Don't ask me if I'm getting the accent right, because like I just said, I don't know where the hell that guy was from. He was kind of olive-skinned, not quite brown, not quite, I don't know. He's a weird-looking guy, though. Hilarious. Just absolutely hilarious. I love characters. I love just rich, individual, crazy, unique people. I love that. One of my favorite things about New Orleans, actually. The intercultural character. Anyway. So, it is 4 o'clock in the morning here in Louisiana. And we are talking reef and coastal restoration here on the EasyReefers channel. And that is because these things need to be done together. Now, coastal restoration is how you clean the top off water. But it can only do so much. Now here in Louisiana, it can do more than other places because we have an extensive delta and marsh system. I'm pretty sure Egypt could benefit well from our technologies. But there's a lot of places where the outlets of the river aren't quite as conducive to those types of solutions. And in the case of a river the size of the Mississippi, and with the amount of fertilizer runoff and other chemical runoff that's being dumped into it, there needs to be a multi-pronged approach. We certainly can't just rely on the state and the federal government to restore the coastline. And we certainly can't just rely on the evolution of food production to eventually take advantage of all the available phosphate and nitrate in the Mississippi. But if we unify the effort of coastal and reef restoration by inserting ourselves, the actual aquatic experts, into the agricultural community, we can actually affect real change if and only if our plans are profitable. Now, the train has been chugging and gaining steam and gaining momentum for quite some time when it comes to green energy, when it comes to re-outfitting existing businesses of various types to be more energy efficient, because it's good for the bottom line. And there you have a perfect example of that partnership, which is actually a public-private partnership. It's a public good that's done for private gain. Now, here's the deal. If you can make a facility that can, and let me just go ahead and pull a couple of drawings up, that can sit on a river or on a channel dug off to the side of a river, multiple channels, multiple estuaries, tributaries, and have facilities that use, firstly, the chemicals in the water to grow algae for biodiesel and for other natural products that are in developed polymers and fibrous resins. Dingo, you're snoring. My dog, Dingo, stop snoring. Jeez. If you didn't have your face like that. Weird old dog. So, anyways, what I was saying is you need to have sort of a revolution in food production that's based on energy efficiency and materials efficiency. So that means having a first stage of decontamination of more toxic sources due to the chemical plants being a factor, as well as fertilizer and nitrate runoff. And what you're going to want to do is use natural filtration that grows algae for biodiesel to take care of the heavy elements. So what this will do is take all of the minerals, the metals, the carcinogens, and provides a settling pool for them. Okay, well, what you need to do, I don't I don't have that drawn up here in this particular drawing because this is all pretty standardized, known process. It just hasn't been used for this reason. Okay? But what you have, and I'll go ahead and just make myself a new camera so I can use my arms and gesture about like a spastic flailing person. Okay. Hi. Oh, I gotta change that backwards because it's opposite. Do a little dance with myself. Now. Okay. So, algae-based biodiesel production is as simple as having very large, flat pools that are illuminated by sunlight during the day, and you'd want to, for maximum production, have some high power focused blue and red only lighting at night. Now, what you would do is essentially have these pools filled, let the water stagnate in stages, have like a valve open once a day, let the water in, something like that, and then staged after that water sits for a week in this pool, the water drains out, and then you scrape and harvest the algae. That seems to me like the most efficient way to get the water cleaned at the level that you would want to be able to use it for further production processes. Now, from that point, the algae is good for use in macroalgae that can be fed to fish and in some forms of livestock as well. Not that that's really a problem, but fish feed, that's handy, especially as highly nutrient dense as it is. And then from there, that further processing by those plants prepares the water for UV sterilization. And then with a small sterile nitrate infusion can be used to grow phytoplankton. That phytoplankton in turn is used to grow microbial zooplankton, or tiny, tiny little crustaceans that the tiniest little baby fish can eat. And you can set up a facility that can resist any sort of damage to your investment, that can grow out fish from larvae all the way to either ornamental sales or food fish sales. Now, there's a key thing. A key thing to saving the environment is getting people to buy fish tanks. Now, if I wanted to make money, I would remain in the car business. But I'm trying to save the world. But I know about the car business. Know what I'm saying? And to sell a car, it's the same as selling an idea. It's the same as selling a political run for office. It's the same as selling a business friendship. And to sell this idea, we need to sell this business friendship. The only people that know about coastal and reef restoration are people who got into it during college, or they're in politics, or their hobby in some way involves that park, involves that wildlife sanctuary. And generally speaking, when it comes to the ocean and to the coastline, there's only two groups of people that have any economic power. Fishermen, big hobby, it's covered. That's what current coastal restoration efforts are centered towards attracting. But they haven't figured out a way to make money off of it yet. I can help them with that. But the other one is the home hobby aquarist. People who keep freshwater or saltwater tanks. They should be incentivized, pressured. They should be made to feel like it's cool, like it is the status achievement, the goal, the ultimate bragging rights for your home aquarium to help with coastal and reef restoration. These people can participate and provide minimal, albeit minimal, physical, logistical contributions to saving the world. And by allowing them to participate, you do two things. You create interest in the actual restoration process, but you also give room for that hobby to expand and create even more interest and more understanding. It's actually an exponential thing where the environmentalists, the animal conservationists, all come to an awakening, okay? We have to coordinate it with them. We have to plead with them to recognize that reef tanks aren't some form of animal subjugation. We are not being cruel to these animals. They are spoiled and live twice as long in our tanks as they do in the wild. Okay? How many different animals are kept in captivity that live twice as long as they do in the wild? If you're doing that, you're doing something right. And the fact of the matter is, we can actually create a new sub-branding of aquatic hobbyists that keeps almost, or exclusively even. I mean, I was thinking you could have like a percentage standard where you could call it that, you know, but you could basically have an exclusive aquacultured fish tank trend. It's already happening. We just need to brand it, package it, get governments, get politicians, get states, and get businesses involved. They need to see why the cross-marketing of the aquarium hobby is going to help them sustain their fisheries out in the ocean. Because we're not collectors on a massive scale. People who keep aquariums, most of the collection done in the wild is done by the people who live out there. Okay? And these people understand that if they overfish their local reefs, they're not going to be able to continue to feed their families. Most of these places that provide these fish have been doing so for more than 30 years. Now, now that I've covered pretty much what I want to talk about as far as the food structures go, let me just talk a little bit about the environment itself and about how it's being affected. By and large, as well as some misconceptions regarding the cause of coral bleaching itself. Okay. Now, I've been keeping reef aquaria for 30 years now. Okay. Actually 31 years, but who's counting? And let me just put this up here so I can concentrate on what I'm saying. Okay. Been a long day, starting to get tired. It's currently the next day. I suppose I'll take a little nap sooner or later. Give me a little 6 to 9 rest period. I'm sure most people don't find 6 to 9 very restful, but yeah. As for me, anyways, so in 30 years, I have been keenly observing many reef stores, many public and private aquariums that both friends and professionals have been keeping. I've known who Julian Sprung was since the late 80s. Used to read his articles and thought he was just the coolest guy. Got to meet him at Macna, shake his hand. Made me happy. Now, in that time, I have kept many different species of marine organisms. Just coral, shrimp, fish, crabs, stuff from the store, stuff from the beach. Done all kinds of fun stuff. But one thing I've always been keen on really narrowing down my observations into a confluent understanding is the sea anemone. Now, in my reef tank over yonder, which has its lights off, that is a 20-gallon long, and I have 2 rose bubble tips in there. That's the Emancipida quadricolor anemone. I'm just gonna. I have total dyslexia when it comes to pronouncing that fucking first part of that name, so I'm gonna just look it up right quick so I can sound it out so I don't sound too much like a moron. Entasmia. I don't know why I always want to be like Emancipation Proclamation anemone. I don't know. Sometimes even my brain gets stuck on stupid. How about that? So, anyways, in keeping these anemones for so long, and I'll go ahead and pull up some images. How about that? In keeping these anemones so long, especially while breeding clownfish, I've noticed some things that cleared up many of my observations on corals. Now you see, in keeping corals, especially SPS, acropora, hard branching corals, the modern aquarium hobbyist and mariculturalist or coral grower fragger people they've noticed that the same coral, same species, from the same cut from the wild, eventually turns different colors in different systems. Sometimes with the same lighting, sometimes not. Now, this is not really complicated, but it's been kind of a mystery among hobbyists, and it seems to be not yet understood by even the very renowned and very accomplished Great Barrier Reef scientists that I've been observing out in Australia and New Zealand. Now, observing anemones, I have seen dramatic changes when it comes to trace element levels and nitrate levels and phosphate levels, as well as iodide, salinity, and temperature. And what seems to happen over a long period of time is that a sea anemone, which is basically like a very large coral polyp when it comes down to how it eats and metabolizes. A sea anemone can basically manipulate its own little crop of zooxanthellae. Now, for those of you who don't know what zooxanthellae is, it's basically this little tiny blood substitute that kind of acts like chlorophyll for plants but it does it for coral. Okay. So it's basically the chlorophyll of anything marine invertebrate based that isn't a plant. It's not a pigment like land-based animals would have. It's basically an algae that has its own plant-type material in it that the coral, or in this case an anemone, grows within its cells, along the surface of its cells, in order to provide itself energy via the photosynthesis of the zooxanthellae. It's a very complicated arrangement, but once understood and just accepted as a given, the effects of zooxanthellae are relatively easy to understand. And to understand it, you basically just have to realize there are different types of zooxanthellae, and each one has a different taste. Each one has a different preference for trace elements, for nutrients, and for photosynthesis level. So some zooxanthellae will enjoy nitrates and phosphates in the water. Some zooxanthellae will enjoy lower light levels. Some zooxanthellae will enjoy higher light levels. Some zooxanthellae will require specific trace elements. And some zooxanthellae don't give a shit. Some zooxanthellae die off at slightly elevated temperatures. Some zooxanthellae thrive and overproduce at elevated temperatures. Now, coral bleaching and rapid tissue necrosis. It is my current perception that the consensus understanding, or the only available data offered, is interpreted as coral bleaching is due to temperature variations exclusively. And they have now begun to investigate genetic differences in corals, that is, the parent organism, the coral, not the zooxanthellae, to further explore what makes them more or less tolerant. But this seems to be a misguided exercise of well-meant expenditure. Because it's not the corals that determine their own temperature tolerance. In fact, it really has little to do with the coral itself. However, adjusting its metabolic rate can cause the coral to stress out and to either eject all of its zooxanthellae and bleach, or to have rapid or even slow tissue necrosis. Usually rapid tissue necrosis. But rapid tissue necrosis is caused by something similar to bleaching, but usually occurs after several bleaching events or the failure to recover from a bleaching event, and then an additional stress factor is added. Now, basically what happens is after the first time a coral partially bleaches due to either a lack of a specific trace element being available, or the lack of or an increase of something else causing other zooxanthellae to overproduce. Okay, so either way, what you wind up having is a die-off inside the coral, inside the skeleton, inside the flesh of the coral. You have zooxanthellae starting to die. Those zooxanthellae create waste. Now, zooxanthellae, to a limited degree, can absorb waste. Guess what type of zooxanthellae can absorb more waste than others? Brown. The brown, common zooxanthellae that's found even in free-swimming jellyfish. So what happens is a lower temperature, lower light coral might experience a slightly higher temperature, or might experience a chemical contaminant. And brown zooxanthellae, being constantly available in the water supply, will begin to form inside of that coral to absorb the extra nutrients. Now, if that contamination continues to increase, or as the trace mineral that is often as a result of a chemical reaction in the water that occurs before the coral even has access to it, that trace mineral deficiency causes further die-off of the other different types of zooxanthellae. That coral will over time turn brown. Now, increases or decreases in various trace minerals, as well as exposure to different types of zooxanthellae in enclosed systems, can cause different variations in color patterns as well. Also, introduction or reduction of trace elements in the wild water supply due to mining activities, or in some cases foliage overgrowth, which absorbs the minerals before they get to the reef, can cause wild color variations, especially when other stress factors come to affect the corals. So what happens in this case is, instead of a nitrate-loving zooxanthellae like the brown being the dominant, it's the trace mineral-loving zooxanthellae that experiences the same sort of metabolic overload, and the coral can begin to fluoresce as that one species of zooxanthellae within the coral overproduces, and then it will bleach. So that's why before some corals bleach, they'll turn brown over a long period of time. When some corals bleach, they're basically poisoning themselves from within. And it's that last attention-getting mechanism in nature that was so profoundly observed on the Chasing Coral movie, where they just seem to glow in the dark. And what they're doing is absorbing cell by cell more and more of that specific trace element that causes that specific fluorescence until it becomes toxic to them. Just as the same happens with the phosphoratic content of the brown zooxanthellae, which, as I said, the overproduction of brown zooxanthellae is probably the most common cause of bleaching and rapid tissue necrosis. The brown zooxanthellae likes the nitrate and the phosphate. And if you'd like some visual proof of that, I do have that available. We can stop the little slideshow. And let me just show you. Unfortunately, I don't have any recent photos to compare these two, so I'll just have to describe. Or you can look on past videos. I think it has been growing. It's been growing so slow I hardly realized it had grown. Wow, it has grown. My turbine area has grown. How about that? So anyways, welcome to my high nutrient system. Okay. This is not the perfect, expensive reef tank with all the equipment. This is an upper reef and a big clownfish broodstock system. I had a whole bunch of little babies that were all kind of runts running around in there. And it was great. And see this right here? This is yellow turbinaria. And as you can see, in my system, it is brown turbinaria. Yellow, low nutrient system. Brown, high nutrient system. Invariably. Tanks with lots of fish. Tanks with sand beds that don't practice regular nutrient export. Tanks that are going to have nitrates even if the nitrate test says no nitrate. You put a coral in there, it's going to turn a little brown. You put an anemone in there, it's going to turn a little brown. Now this anemone right here, that is a rose bubble tip anemone. And as you can see, at that time it wasn't very rosy. But the clownfish still thinks it's cozy. But this anemone came with two others. And they were already bleached when they came in. And they were a little smaller. I didn't have much hope for them. And they eventually shriveled up to nothing. But now, this one here came in a dark brown with green zooxanthellae, and it had a little bit of rose on its tips. But I had underestimated the lighting requirements when I was switching to LEDs from my 4 T5HO setup. 4 T5HOs with a metallic reflector is a pretty decent setup for a 20-gallon long, but it wasn't really enough to keep anemones either. Once I got enough light on there, this anemone started growing back from all the different zooxanthellae it had absorbed from the 2 other rose bubbles that had like a very bright reddish to them. As they were shriveling, it seemed to get redder and oranger. And eventually its green zooxanthellae and its base grew back brilliantly. And about a year later, I got another rose bubble. I figured this one's doing pretty good. Let's put another one in there, see how it does. Now it, even though I have 3 full LED strips, 2 current USAs and 1 Coralite Aqualite S going across that 20-gallon long, and I've probably got around 240, 280 par where those anemones sit. That new anemone wasn't stretching up to the light. Seemed like it was doing just fine. Never even saw it shrivel up, like except for like during the light ramp down when they usually do it before bed, you know, the little temporary shrivel. It's perfectly normal. You see your anemone shriveling up in the middle of the day for several hours, you got temperature problems or something else. But this guy, he was doing just fine. But his color started to get lighter. He never ejected any zooxanthellae. Never. And I was watching him like a hawk. Perfect bubbly tentacles every single day. Consistent cycle every single day. And there was no dramatic change in his coloration. But it came like that other one came, with a lot of that green base to it and the orange tips that this one used to have. This one used to have the green base and the orangish rosy tips. And those 2 bleached ones had the pink rosy tips. And before I had introduced that new rose bubble, this one here had gotten some of its green back, not much, and just had like a mixture of the red and the orange. When I put the new rose bubble in, as it started to fade, it turned redder and pinker and rosier. And this one started to get oranger and greener. For months, this started progressing and got more and more extreme until one was just orange and one was just pink. And now they've started to equalize again. Months later, they've started to equalize again. The new one is starting to get more of the green and the orange back. And this one here is starting to get a little more pink again. And both of them are as healthy as can be. And I actually have to regulate their feeding so they don't grow too big. My adult clownfish can sleep in them now. That one right there is a baby. In fact, I have both of my mated Truperculas are sleeping, one in each anemone right now. So, in addition to this, what you can observe about the zooxanthellae and anemones is that a bleached anemone, if fed daily, and if it's not so large that the weighting of the feeding increment stresses it out and it can maintain itself, it can actually eventually regain its zooxanthellae. It's not going to work well with a small anemone, like I said, but the zooxanthellae will transfer. And high nitrates, especially with rose bubble, a reasonable amount of nitrates, not something that's going to kill coral or anything, seems to actually help this process. And it seems to me like not just with this pair of anemones, but with many other anemones I've seen in captivity, that little bit of nitrate that comes from the sand bed will help the anemone grow a brown zooxanthellae that can deal with a wider range of lighting conditions. Now see, in the wild, anemones like a lot of light. You might have a really expensive lighting rig, okay, like take Scott Anderson from Mile High Reefers. I'm sure his lighting is astronomically expensive. His reef tank is amazing, and there's no reason why he should put more light on it. But because it's such a big system, and because he's got sand in there, because there's a little bit of trace nitrate no matter if it comes up on a test or not, that anemone, the sea bay that he has, I believe, and I think Mark Levinson has one. Whose anemone am I thinking of right now? Both of them, actually, I believe, have sea bays. Sitting lower in the tank, okay, in a spot where they would be comfortable in the wild, but because it's in an aquarium, they're not getting that much light. But that little bit of nitrate has actually been beneficial to those anemones and allowed them to grow that slight excess in brown zooxanthellae, which allows them to adjust to the medium light. They can simply turn a little browner, absorb a little more light, for their depth and maintain themselves just fine. Now, I don't know whether it's a coincidence as far as the rate of metabolism, whether it's augmented by the nitrates, or whether it's a simple matter of brown being a darker color attracts more light. So you'll have a higher rate of absorption as opposed to reflection with browns as in total. So then consider that effect when it comes to coral bleaching. If a coral is turning brown or darkening in some way, it's going to absorb more heat energy from the light, further exacerbating its condition. So without the presence of excess trace minerals, without the presence of excess nitrates and phosphates, you don't have that browning, you don't have those different darkenings occurring, and the corals remain resilient to bleaching. And just bear in mind, temperature and salinity, those can irritate a coral, but they're not going to kill it. Not unless there is an ongoing stress cause. Now, if subtle, if slow enough over time, an ongoing stress cause can even be adapted to. But if those other factors cause additional stresses, then the coral never gets a chance. But anyways, I think that is all for this particular broadcast. Let's see, we talked about getting reef hobbyists as a new fad, to be the cheerleaders, to be the civilian educators for coastal and reef restoration. We talked about parts of my plans to my many wide-ranging plans for everything that also happen to include ways to make coastal and reef restoration profitable while helping spread that enthusiasm. And then what I did just now, I hope it helps. I gave you my observations as a 30-year veteran of this study, of this, you want to call it a hobby, go ahead. I've been looking at it as a scientific study of enclosed marine ecological systems since I was a child. I have always thought of it as a scientific study. But then again, I'm a nerd. You know, everything for me is science. Even my own life, even my spirituality is science. Constantly testing, constantly looking for variables and changes and constants. So, doesn't look like anybody joined me this evening for the live stream, which is, you know, of course, ridiculous. But, oh well. Hopefully the people in the future who see this will learn something. Maybe even feel like they can do something And maybe, if you share this link and find some more people, get interested, get active, get involved, and possibly support this channel, we can get to work, people. That's what this is about. This is going to take work. You gotta work before you can have fun, right? Well, in our case, we gotta work before anybody can have fun. Or, let's just say they won't be having fun for long unless we get to work. Yeah? So I'm gonna get my ass a nap in, I suppose, because I'm pretty damn tired. Thanks for watching. Click that like button if you don't mind. And like I said, please share this video. Try to get people interested in whatever your state's coastal or river or whatever bodies of water you have. Get people involved in keeping them clean, because the lives of our children depend on it. Thanks once again for watching. Y'all take it easy, but don't take it all. Peace.